So guys, do we have any questions at this point? All right.
No, not really.
Okay, good. Good. I said good.
Oh, wait. I do have one.
And that's good too. I was trying to explain myself. Go ahead.
All right.
I'm listening.
So the exam will be covering over P1, P2, and P3.
Well, not
Right?
necessarily. No, not necessarily. The exam is on the 22nd. Whatever we cover up to the 22nd will be covered on the exam. I haven't
Oh,
decided.
so you'll make the exam. You'll make the exam the day before it happens to make it like coincide.
Good question. I don't quite wait till the last moment, but I'll probably make it a little before that, but I can always, it's an online exam. It's very easy to change. So generally, it's a good question that you're asking. Let's say the exam, I'm making it up. Let's say the exam is, all my exams are cumulative. So let's say our exam 2 is on the, I'm making it up again, on the 30th of June. So whatever we do will be covered. And I will clearly mention it in the announcement section. I'm going to say something like exam 1 is on this day. These are the sections I will cover. I will give you a few of the problems that you should focus on. I know it's a lot. So I will identify some of the problems that are more aligned with what I'll give you. So it'll help you focus a little bit, but you do want to practice the easy ones too. Does that answer your question?
Yes.
Okay, I don't want to decide right now what the cutoff point is, because then when I will teach you, let's say I did, okay, let's say I said, okay, up to P3, then I'm going to be doing P4 before exam 1. Nobody will be paying attention. Oh, it's not going to be on the exam. Okay, so that's one reason. So exams are cumulative. Do the homework. I will post some of the more quote unquote important problems in your syllabus, or I call it study guide. I would say, okay, from P1, do these, from P2, do these. And at the same time, you want to do, I don't know what you can see, you want to do the MATLAB problems, okay? They're really similar and it'll give you some extra practice. What other questions? Go ahead, I'm listening.
So the P1, P2, that's all MATLAB, right?
P1, P2, I believe P3 is also on MATLAB. I made P3 yesterday. If I'm
okay. So you're gonna put in the announcement what problems we should focus on.
Good question. So what I would well, the way I see it, don't use this to assume that, oh, I don't have to study out. I'll give you some of the important problems, so you'll see a lot of them from there. Okay. I can even give you a hint right now that
okay.
when I
those are like,
go ahead.
So like you're gonna give us like ones that we should focus on to get like the basics down of what we're learning in those sections.
Somewhat.
Like you'll give us some of the hard ones and then some of the like cover the basics, right?
Right. So the way I do it, I'm gonna go through this pack. Can you see my screen? Can you see my screen?
We can.
Good. So let's say
I can't speak for everyone, but I can see it.
Okay, good. I mean, okay. So let's say I assigned a lot here, right? You could argue. So I will say, okay, from 1 through 64, you want to make sure you do 17, 18, 19, 20, 21, 22. I'm going to rewrite those numbers. And from this group, I want you to, let's say, do 41 through 48. Okay. And from this group, let's say I want you to do the last 4. So I will give you a slightly compressed version. Don't count on it. Slightly compressed. Why? Because I want you to practice a little more. And one more thing, if you don't understand the easy ones, you won't be able to do the hard ones. So that's why there's a lot of homework problems there for you to practice. If you don't want to practice all, that's fine. You're like, I know how to do 27. I don't have to do 28, 29. But if you want to, you can do it for practice. It could only help you. Does that make any sense?
Yeah.
Okay. Well, thanks for asking the questions. Other people have those same questions, I believe. Any other questions from anyone, guys? So I would encourage you, or like last time somebody said, urge you to do all the problems, okay? And don't wait till the last moment. And I would also ask you to ask me questions like, I couldn't do number 38. Can you show it? Those things are totally fine. If you ask me questions from the text, you can just give me the section number and problem number. I will be able to do it. If you ask me something from MATLAB, you have to really take a screenshot and email it to me. All right? Because I can go to MATLAB. Two problems with my going to MATLAB. If I go to MATLAB, I don't see exactly what you guys see. I do see the answers and everything, number one. Number two, it always shows me a different problem. Every time I click it, I get a different version of the problem. So just be aware of those little things. So how are we, what else, guys? How are we doing so far? Are we doing okay?
Yeah, we're doing okay.
Okay, good. So guys, here's what I'm thinking. We're going to start P3 a little bit. And after P3, P3 is not hard really. I don't think we're doing things that are too difficult, but eventually we'll get to things that are a bit more difficult. Anyway, so here's what I was thinking. I can go back and check my video. Does anybody remember if we did 43, 44 from P2 yesterday?
No, we mostly did P1 problems.
No,
towards the end.
we did.
And then we did.
We did some of the P2 stuff, guys. I remember.
We went up to
No,
question 42 for P2.
Okay, exactly. That makes sense. Exactly. Thank you. Who's talking? Amara?
Yes.
Thank you for pointing out. I think that's kind of where I was, somewhere here. We did up to 42. Of course, I didn't do all of them. I'm aware of it. Okay. There's no point in doing all of them. Then listening is a good way to learn, but doing it is even better. Now, I'm not saying I'm not going to talk. So I'll do some. Again, you can always say, well, I tried number 30. I couldn't do it. Can you do it? I'll do it. Okay. All right. So guys, I'll take this. I'll take what Amara just said. 41, 42 is roughly, that's where we stop. So
can we do 41 real quick?
Of course.
That one.
I'll be happy to do 41. Let's start with 41. All right. Awesome, guys. Let's see. Try to interact. It's a little hard for everyone because, you know, I feel like it's nice that some of you talk. That's good. That makes it a little more real. So I'm going to start with 41. This is P2, second section. Okay. Excuse me. All right, guys. So again, this is P as in pencil, pencil 2. All right. So guys, remember we said whenever you have a power and a negative sign, stay alert. If the power is odd, the sign will remain. If the power is even, the sign will vanish. And the explanation is -1 times -1 is +1. So if you put 3, there is an extra 1. If you put 5, 2 of the first negative ones will make it positive. Then the second set of negative ones will make it positive. And there's one extra dangling one that's going to make it negative. Okay. So -1 times -1 times -1 is not +1, but -1. Odd powers, sign, negative sign stays. Even power, negative sign can be ignored. So let's get rid of this. Let's see what's going on here. So I'm going to say, I am going to pretend, and I show all the steps, okay? When you're doing it on your own, you can skip a couple of steps. I'm going to say this is really based on what we discussed. This is really this problem. I stuck the negative sign out, okay? Now, this guy here simply means, don't forget the negative, 4 to the power 3. We said a power outside parenthesis should be applied to everything inside the parenthesis properly. And your calculator will tell you 4 to the third is 4 times 4 times 4, which is 16 to, I think it's 64. I'm going to double check real quick on my calculator. 16 times. Yeah, I think that's right.
You're right.
Okay, good, good. So that's our 41. I'm going to pause it a little bit, okay? Because in class, when I teach this in a physical environment, I would give a problem, students will try. And I am thinking that I would encourage you to do the same sometime. I'll give you a good 5 minutes. I'll go get a cup of tea, ask you to try something. And then if you want to share. Now, most of you, I shouldn't say most, some of you wouldn't be comfortable or you're in a position where you can't share your screen. But some of you will, I know that. So that's our 41. I'll do that a little bit. It'll slow us down a little bit. All right, moving on. Okay, so this 42 is very similar. Let's try 44. Let's try 44. Again, a couple of things we are kind of collecting or gathering. If you have a negative sign, odd power, the sign stays. So I'm going to rewrite it as follows. I'm going to say this is same as negative 3x to the power 4 yx to the power 6, and the whole thing raised to the power 3. Because 3 is odd, I have a negative sign outside. Now this power 3 right here belongs to this little 3, this x to the power 4, and this y to the power 6. So I'm going to rewrite it. Even though you don't have to, you can directly apply it. I'm going to rewrite it like this: 3 to the power 3rd, x to the power 4 to the power 3rd, y to the power 6 to the power 3. So this 3, the power 3, applies to each component. All right. 3 to the power 3 to the power 3 is simply 3 written 3 times and multiplied. I think that's 27. Okay, x has these two powers. Remember, guys, we multiply them. So 3 times 4 is 12. Again, y has these two powers, 6 and 3. We multiply them. And that's our final answer. And do not forget the minus sign. A little pause for you to see the steps and process it. We are good, guys? All right, seems like we are okay. All right, so let's try. I'm not going to worry about this. I tend to do the even ones. I think they are, the answers are, the odd ones are in the book and all that, but I can do any one. I'm going to do 46, guys, okay? I'm going to do 46. And if you want me to pause, you want to say, hey, I'm still copying, or, you know, can you explain that again? Just say it. Just say it. Okay, this is 46. So a couple of things, guys. I have a cluster here. I have a cluster here, and they're all being multiplied. 11 is being multiplied by x to the power 4. X to the power 5. 9 is being multiplied. And this is a multiplication sign here as well. All right. So I'm going to kind of rewrite by collecting the like terms. Like terms would be 11 times. You don't have to, but I'm going to rewrite it. 11 times 9. Then I'm going to take x to the power 5 and x to the power 12 and write them here. Now, this is a multiplication sign, okay? So it doesn't look very different from X, and my apologies. Okay, 9 times 11 is 99. Who's going to tell me what x to the power 5 times x to the power 12 is? Unmute yourself.
60.
Sorry?
60.
No, remember guys, when you multiply the powers like this, you add the powers, remember?
Oh, sorry. Sorry,
It's
my
okay,
bad.
no big deal.
17.
Thank
17
you.
then.
Thank you very much. X to the power 17. And I'm done. I'm done. Once again, I'm going to write it here on the side. However, if I have something like this, now I'm going to say 3 times 4 is 12. You want to make sure you understand the difference between the two. So that's our 46. A little pause, little 30-second pause. All right, guys. If I'm going too fast, all you have to do is, can you slow down? Can you say that again? All those things. Awesome. I think we're making good progress. So right here, I'm going to try 48. Again, good old rule, negative times negative is positive, and like terms are all collected together. All those things that we have been seeing, we have been doing are going to come up over and over again. So I'm going to say, I'm going to just, if I may, negative times negative is positive. I'm just going to ignore them like so. Okay, now I'm going to multiply the numbers. I'm going to show a few extra steps. What difference does it make? Everything is being multiplied, guys. X to the 4 times x to the 7. I'm gonna ignore the multiplication sign because it kind of looks like X. I'm going to use a dot for at least these problems. Okay, this one I'm going to do it for you. 5 times 6 is 30. Who's going to tell me what x to the 4 times x to the 7 is, guys? What's x to the 4 multiplied by x to the 7?
11.
Thank you very much. And what's this? Y times y to the 11? What's the power
12.
of? Thank you. It's 11 plus 1 is 12. Thank you very much. And just to let you know, as we have discussed, there's a little y, and I'm done. I'm done. The answer is the bases are different. Don't add them. Say xy to the power 23. That would be incorrect. The bases have to add the powers. The bases have to be the same. Let me go back. Okay, I'm kind of reviewing. I know. Bases have to be the same. Y, x, number. A little pause. I'm pausing a little bit on purpose. See if people have any questions. All right, guys. A couple of harder ones. I'll do a so-called easier one. Well, actually, these are not that easy. They're as hard as they get in this section. Let me do 108. Let me do 108, P2 again. All right. So a couple of things, a lot going on here. The negative powers, I can move them up or down and change them. But I'm not going to worry about it yet. I could, but I won't. So if you want, I can. So just to let you know, guys, a lot of these problems can be done in multiple ways. All right. So I'm going to say, well, let me do one more thing actually here. in for some reason. Oh yeah, here. You don't have to worry about it, but it was for me. Okay, so this power belongs to everything here. Okay. Again, do you have to do exactly the way I'm doing? Not really. There are a few alternates and I'm using one of them. So I'm going to say x raised to the power -2. That's this -2. And then y raised to the power -2 times that raised to the power -2. This -2 comes from here. And this -2 comes from here.
Would that turn it to +4?
Correct. And I'm going to do it on my next step. Correct. You're absolutely right. X -2 is here. And this -3 belongs to it as well. And like, is that Jack or John?
Jack.
Jack, the way you're suggesting, it'll apply here too. And this is this. All right. So guys, x to the I'm going to the numerator, which is simply x to the -2. And remember, guys, we multiply the powers, and like Jack is suggesting, -2 times -2, not adding, multiplying is y to the power 4. Easy to make that mistake. Okay, -2 and -3. When you multiply, it's +6. And this is not much going on. Okay, so what I'm going to do, guys, I'm going to write it nicely. So I try to show all the steps, but of course, when you're doing it on your own, if you understand a step, you can skip very carefully. What I'm going to do now, I can apply some of the formulas I know I can, but I won't. I'm going to make this y to the -3rd go up. I'm going to put it right here, and it'll be +3. And this y to the 4 is okay. I'm okay with it, because the power is positive. X to the 6 is okay down here, no problem. X to the -2 has a negative power. I don't like negative powers. I'm going to bring it down and make the power positive. It looks much cleaner to me. Of course, it's a preference. Some people can directly apply it. I don't see a problem, but if you don't mind, I'm going to move it a little bit, or we can even do this. Okay, one more step and we're good to go. We're done. This one is easy. Y to the 3rd times y to the 4th. You add the powers. X to the 6th times x to the 2nd. X to the 6th power times x to the 2nd power. You add the powers. 6 plus 2, not 6 times 2. And that's my answer. Done. Not that bad.
Okay, so the -3 exponent changed when it moved up, right?
Correct. Let me find out which one you're talking about. When you say -3, which one are you referring to, John?
I'm talking to when you brought the y -3 up to where the x -2 was. It changed in turn into
You're
that.
absolutely right. You're absolutely right. If this is what you're talking about, yes. And the same thing goes on here. Is that what you're referring to?
Yeah.
Yeah, that's correct. Whenever I personally, you can add and do all those, as I said, you can do this problem in a couple of different ways. I personally don't like to see the powers as negatives. I don't, but you can actually, you could have done 6 minus 2 and all those things, and that'll be fine. All the rules we learned, you can apply them, but certain rules can be applied in a slightly different order, okay? So I did it this way, and that's a valid way to do it. And negative signs are a little more challenging to deal with. So I prefer to change them to positive whenever I can. Not forcefully, but if it's a valid step, I will do it. What other questions, guys?
I think I'm all good.
Good. And thank you for asking. And I will encourage other people to ask too if you have any questions. Okay, good. Okay, so moving on. All right, we did. I'm going to try 110. I'm actually going to try 110 and 12, and that's going to hopefully. Oh, we have a bunch. We'll see how far we go. I'm not going to worry about it too much. Well, let's try 110. Didn't realize, I thought we were almost done. 110. And if we don't go to the next section, okay, don't email me saying, do we have to do MATLAB? So the real rule is once I wrap up a section, you should be able to do all the MATLAB problems. So if P3 is sitting there, don't worry. I'm not gonna, I'm not gonna go check if you're working on it, but you want to do it after I'm done. That's the best time to do it. It gives you a chance to practice and make sure you understand what it is that you're doing. Okay, guys, back to this. So this is not that bad. I think I'm going to do it like this, and you can do it in a couple of different ways. I'm going to say this -3 power belongs to this. Let me do one more thing, guys. Okay, this -3 power belongs to 3 and x, this guy. All right. And I don't have to worry about this too much. So I'm going to just say this is 3x -4y z -7. I didn't do a whole lot. I just copied it. Now this is 3 to the power -3 and x to the power -3. Again, it's a preference. I don't like negative powers. Okay, so the first thing I'm going to do is I'm going to keep the powers that are positive on top and negative powers will come to the bottom. Again, it's a preference. So this one, I'm going to write it like this. The y stays here. Okay, very carefully. I'm going to put x to the -4 here, and I'm going to forget the negative sign. Z to the -7 here. I'm going to forget the negative sign, and don't forget 3 to the -3rd, I'm going to write it here, 3 to the 3rd, and x to the -3rd, I'm going to write here, x to the positive 3rd. Now it looks much cleaner to me. Now I'm going to do it on the side, guys, 3 times. So just look at this 3, and this 3 to the 3rd. I'm going to do it on the side, 3 and 3 to the 3rd. This is 3. This is 3 times 3 times 3. I'm going to cancel. And I'm going to get 3 to the 2nd. So again, I'm going to cancel. Let's do it in green. This guy and this guy, they cancel, so to speak. And in the bottom, I'm left with 3 to the 2nd. Of course, actually, I'm going to use my red color. I'm going to make it 3 square. Okay, nothing, y has no buddies, so leave y alone. Z has no buddies, leave z alone. Well, before we get to z, x to the 4th, x to the 3rd, you add the powers and you get x to the 7 and z to the 7. And excuse me for making a big mess. Now you can leave it like that. A few people will tell you, I don't like 3 square. I prefer 9. Sure, I can do that. You can say y over 9, x to the 7, z to the 7. And that's your answer. This, I'm going to erase this. This is a little bit of a distraction, okay? So take a look. Tell me what you think. So the tendency is we leave our answer with positive powers, okay? If you don't do it, am I going to take off points? Not necessarily, but that's the convention. When you're going to MATLAB, you probably will have to do it. That's what they expect. You'll figure it out.
Could you just leave it on there for a little bit
Of course,
longer?
of course, of course.
Thank you.
Sure. Anyone else have any questions? Here's the deal, guys. This is gonna tell me that it's gonna shut us down any moment, which is not a bad time. Again, it's not a break. I'm gonna come back using the same link. I'm gonna return in a minute and we'll continue working on the same section. I'll see you soon. We're not going anywhere. Bye. Bye for like 2 minutes.